Hello, I'm Param Singh. Hope you guys are doing well. We have covered quite a bit of ground in learning Elixir, and I thought it would be nice to review our Elixir story so far before we continue. So, in summary, everything in Elixir is an expression which, when run by the Elixir runtime, it evaluates to a value. Computing is essentially transforming data using functions. So we use functions to take some piece of data, do some computations with it, and then produce new kind of data that we can use further. What that means is that we typically work with multi-step data transformations, which is accomplished using function composition. Elixir programs are organized in modules, and a module contains one or more function definitions and attributes. We learned about a function design recipe. So, what is that recipe? So, we start with a signature, which essentially tells you two key pieces of information. One is the name of the function, and the second is the types of arguments and return values. Then we move on to writing the purpose, which means what is this function specifically going to do? Not how it would do, but what exactly does this function do? In the third step, we write the stub of the function, which is the function definition, but without any implementation. We put in a default value of the type that the function is expected to produce, so that in the next step we are able to write our tests and run those tests successfully. Which means in step 4 we start to think about some examples, which allows us to think concrete use cases of the function and also helps us to write the tests for those cases. And then in step 5, we get to a point to finally implement the function and write its body. And at that point, we already have done enough work that writing the body does not become trivial, but still allows us to write more systematically compared to if we were to write it without the first 4 steps in place. And then once we have written the body, then we do test, which is mix test, and debug if needed. And the debugging process would take us back to all of these steps depending on where the problem is. So we may have a test that is written incorrectly. We may have an implementation that is not correct. Our purpose may not match the implementation, or our signature may not match the purpose or the implementation, and so on and so forth. So we continue this process until we have all the tests that are passing, and then we move on to write our next function. There are many attributes that Elixir provides to do the function design as well as the design of our entire programs in a more systematic way. So far we have studied 3. The first one is @spec. This allows us to specify the function signature. The second one is @doc. It allows us to document our function. And the third one was the @type attribute. This allows us to define our own custom types. Then moving on to the match operator, which is this equal to sign. So the way it works is the right hand side is an expression that is first evaluated to a value, and then it is matched with the structure on the left hand side. And if the match is found, then Elixir will bind those values on the right hand side to the variables on the left hand side. So in this simplest example, 1 already is a value. On the left hand side, we only have one variable. So Elixir can bind the value of 1 to x to create a match. Then x can be used later in the program. As far as the kind of data is concerned, we have only looked at the atomic data types so far, and we learned about 4 atomic data types. The first one is the numbers. So that contains your integers and floats, and it is used to represent any number or numeric information in your program. The second is the booleans, which only is true and false, and that is used to represent logical information in your program. Third is the string. For example, hello. Strings are written inside double quotes, and these are used to represent any textual information in your program. And lastly, we studied about atoms, which are represented by colon followed by string of characters, and these are used to represent enumerations, which are finite number of distinct elements in your program. We looked at how multiple function clauses can be used to leverage Elixir's powerful pattern matching mechanisms to call different function implementations depending on different kinds of patterns. So first kind of patterns we study was the number of parameters. So a function that will match the number of parameters will be called if there are multiple function definitions of the same name. So in this example, first function will be called if we are calling it with one parameter. Second will be called if we are calling it with two parameters. Then there is a exact value match. So if we use an exact value inside the function's argument parentheses, that particular function will be called based on the value match. And then finally, we looked at the guard clauses, which allows us to conditionally choose the clause depending upon which Boolean condition is evaluated to true. And then finally, going back to our function composition as one of the key mechanisms through which we are going to create larger programs, Elixir provides this pipe operator to simplify writing function composition. So in mathematics, you write a function composition like so: f of g of x, meaning to evaluate this expression, we first evaluate g of x, and the value or the answer of that expression is fed as an input to the function f, and that's what is evaluated. You can write it exactly the same way in Elixir, but readability is diminished in real expressions when we are writing function composition like this traditional, using this traditional method. But instead, if we use the pipe operator, we can see the flow of data, and that's what matches exactly with our thinking that function programming is all about data transformations. So we start with the initial data x. It is piped using this pipe operator to the function g, and the output of that is piped to the function f to get the final answer. So that's it for now. Join me in the next video where we extend the kinds of data that we are going to work with from atomic data to compound data so we can solve more interesting problems in Elixir.